Good afternoon to one and all present over here. Today we will see about Sprue Part 2. So requirements of sprue: diameter, length, number, location, angulation, sprue wax pattern joint. So coming on to diameter, diameter of the sprue is the most important factor in dictating the speed in which the melt enters and fills the mold. Melt velocity is directly proportional to the sprue diameter. Basically, for most of the cast material, the sprue diameter should be greater than the thickest part of the wax pattern. It should neither be too large nor too small. The most important factor is the speed of filling the mold should not be faster than the speed of evacuation of the gases and air from the mold. So this will cause mixture of cast materials and gases in the mold, which will lead to porous or incomplete casting. So generally the sprue former diameter will be between 8 to 18 gauge. For molars and metal ceramic restorations it will be of 10 gauge, and for premolars and partial coverage restorations sprues will be made of 12 gauge diameter. So normally the sprue diameter will vary between 10 and 12 gauge. Okay, so sprue former diameter for small inlays it will be 1.5 mm, for larger inlays it will be 1.7 mm, for onlays 2.1 mm, and for larger patterns 2.6 mm. So now coming on to length, factors governing the sprue length will be length of the ring and the spatial location of the pattern within the ring. So first factor governing the length will be the end of the wax pattern that is away from the sprue should be within 1/8 to 1/4 inches from the end of the ring to allow the minimum thickness of the investment. So this is why is to withstand metal impact and allow the escape of mold gases. So longer the ring, longer the sprue, wider will be the sprue to compensate for the slow ingress due to length it must travel. So if it's too short, gases cannot be completely vented out. Okay, so it should be of adequate length. So coming on to second factor governing length, spatial location of pattern within the ring. This location is essential in determining the way the wax pattern encounters the differential expansion of the investment around the mold. This spatial location can be governed by the sprue length. Now coming on to third factor, number. Single sprue. So determined by the configuration of the wax pattern, the sprue should be attached to the thickest part of the pattern in a way that will allow the melt to flow uninterrupted from the sprue to the furthest end of the mold. The pattern should maintain the same dimension or be decreased in dimension from the sprue end to the other end. So for this case, one sprue is sufficient. Multiple sprues. If the wax pattern have a thin area between the sprue and the periphery of the pattern, the melt will solidify at this reduced cross-sectional area, preventing the filling of the furthest part of the mold. So 2 or more sprues are essential to completely fill the mold in those cases. If multiple sprues are used after being attached to the wax pattern separately, they should join together at the crucible former level in a reservoir larger in diameter than all sprues combined. Okay, in case of two sprues where we have direct and indirect type, so in case of direct type we have V and Y. So Y is most commonly used in cases of MOD inlay restorations, and this indirect pattern is a stable shaped one. So few sprues of larger diameter are used rather than several smaller sprues in case of multiple sprues. Keep as short and as direct as possible. Avoid abrupt changes in direction. Avoid T-shaped junctions. Reinforce all junctions with additional wax to prevent constrictions in the sprue channel and to prevent V-shaped sections of investment that might break away and be carried into the casting. Coming on to location of sprue, the sprue should be attached to the bulkiest part of the wax pattern, and the reasons are to minimize the effect of released residual stresses by the heat of attaching the sprue, ensures that the thinner cross section of the mold will be completely filled. The melt will always be fluid enough and available until all lesser dimensions are completely filled. So it should always be located in the least anatomical area in the wax pattern where there is no groove, cuspal anatomy, fossa or ridges. Proximal surfaces are the ideal location. Normally, the largest non-functional cusp is used in case of posteriors and in case of anterior tooth mid-incisal region. So coming on to sprue wax pattern joint, it should be attached to the portion of the pattern with largest cross-sectional area, and the sprue's point of attachment to the wax pattern should be smooth to minimize turbulence. Generally, it must be flat to facilitate the entry of the alloy and unobstructed flow, and stress breaker like sticky waxes can be added to avoid any stresses being built up at the point of attachment. Thank you.